Um, so first and foremost, welcome everyone. Thank you for tuning in to Smart Water Wednesdays with Ben and Ben. Um, Today's subject will be choosing the correct WeatherTRAK flow sensor for your project. And we have a special guest, Danny Smith, in the house. So uh, Ben, would you like to say good morning to everybody? You got any special messages for this summer morning?
It's just been hot in Petaluma. We had almost 100 degrees here yesterday, which is very abnormal for this part of Sonoma County. I'm guessing everybody is having different experiences, but irrigation season is in full bloom, and ETs are high, so it's a good time to be talking about this. All the systems are being pushed to capacity, and if you've got leaks in those systems, a flow sensor is going to be something you need to make sure that everything gets watered right. Because if you don't have all the right water going at the right time somewhere, if it's going out somewhere it shouldn't be, plants die. So
Absolutely.
this is a good time to check that out.
And I think just adding the ability of a smart controller to watch the gallons and see the actual results of all of our water management work is a huge part of being at that next level of water manager. So
My daughter's 22, right, and home from college, waiting for her grad school program to start. And we've always joked about what I do for a living, but she's now in charge of our garden. And I made her download WeatherTRAK Mobile, and now she can syringe the garden vegetable boxes whenever she wants. And she suddenly appreciates the magic and the power. So it's just a fun way to watch it all come home to roost.
absolutely. I just loaded up my son's device with the same thing. So if I'm not around, he can keep an eye on the gardens as well. So what we're going to jump into here is I'm going to set up this conversation a little bit. Our subject of the day is selecting the proper flow sensor. And so what I'm going to do is kick us off by, first of all, getting this done here. Come on. Show me. There we go. Choosing the correct flow sensor for your, or choosing the correct WeatherTRAK flow sensor for your project. Danny Smith is with us from Park West. He is experiencing a little internet difficulty, I think, but he is on his way back, and we will have him back momentarily. The joys of the internet interview. And while he is logging in, we are going to get started just by talking about a little bit about the hardware that we'll be discussing today. So the thought of today's session is selecting the right hardware. So I just want to cover a little bit about the basics of the hardware that we're talking about, and then we can dive into the details of choosing which one is best for your project. So in this conversation, we'll talk about 3 different types of flow sensors. We'll talk about the T style, the hydrometer style, and the ultrasonic style. The T style flow sensor is really the industry standard. This is the kind of flow sensor that I will inherit on properties if they already have a flow sensor. And so this has been the industry standard for many, many years. This is the data industrials of the world, or the creative sensor technology. If Norm is watching, definitely the creative sensor technology is a great product as well. But we are going to really talk about these as a reference point. Because these have been the industry standard for so long, it's a great place to kind of refer back to. And one thing that we want to focus on in this conversation is, for every flow sensor, there's a number of things that you need to consider. First of all, every flow sensor comes in a variety of sizes, right? In this case, you see the chart that explains that these are available in 1.5 to 4 inch. And every one of those devices is its own unique thing and has to have its own variables that need to be considered. Specifically, the top gallons per minute that it can manage and the bottom gallons per minute, or the maximum gallons per minute and the minimum. So you can see here, for every different type of device, we've detailed the place, the sweet spot where that flow sensor starts to measure flow accurately, and the sweet spot where it stops measuring flow accurately. And both of those are key pieces of the conversation. So now we move into the hydrometer style flow sensor. We call that the WeatherTRAK Flow 3. And we call it the WeatherTRAK Flow 3 because it's got 3 devices in one. It's a water meter, it's a master valve, and it's a flow sensor. We like this because it's easy to install. We kind of think of this as the workhorse of the WeatherTRAK flow sensor world. And you can see again, we're breaking that down just by the minimum and maximum that those flow sensors can handle. And then the last type of flow sensor we're going to discuss today is what we call the ultrasonic style, which is a different type of technology. Instead of using impellers to measure the water running through the pipe, we actually use sound waves. And that increases our resolution. It gives us visibility into flow ranges that the other types of flow sensors really aren't capable of managing. So you can see here, we've got all these different types of flow sensors listed out. And with our classic T-style flow sensor, a 4-inch T-style flow sensor starts measuring flow at 40 gallons a minute. And if we go down to the Flow 3, the Flow 3 starts to measure flow on a 4-inch device at about 21 gallons a minute. So there's a huge difference in between those two types of technologies. And then we get to the ultrasonic style flow sensors, and these guys are designed for high resolution flow information. So you can see here that with a 4-inch iron ultrasonic or an HD iron, you can start to measure flow on a 4-inch pipe at less than a gallon a minute. And with the 4-inch HD plastic, it's at about 4 gallons a minute. So this high resolution data really lets a water manager sink his teeth into all of the different inefficiencies and give visibility into any issues that you might be seeing out on site. Danny, this is where I wanted to kind of get your insight here. As we talk about this, as we talk about selecting the flow sensors, what do you see as the common pitfalls of selecting the wrong flow sensor?
Yeah, I found that it's kind of an
Danny?
industry standard to follow.
Nope. I think
Meter
we're missing your
size,
internet
backflow
connection there,
size,
buddy.
or the existing. Are you okay?
No.
Nope.
Oh,
You're on a serious lag.
You may want to dial in with a cell phone and then just use the web for audio or for video.
While he's, oh, look at that. The hyperlink. While he
we're
is,
gonna try it.
you're doing, oh, that's way better. I can tell
How's that?
already. Yes.
HD? Maybe
Yes.
Flow HD? All righty.
So let's try that again.
Let's try that again. So yeah, the biggest issue that I have found is that everyone likes to follow the meter size or the backflow size, master valve size with the flow sensor size. So if something is 2-inch or a 1-inch, backflow, they want to see that all the way through, including with the flow sensor. We have found it a lot easier to really understand what the performance of the systems are doing, and then selecting the flow sensor that we want to see based on those flow ranges.
Absolutely. And where specifically when you've seen people select the incorrect flow sensor, is it based on that size, and how do we know it's not working for them?
Well, ultimately, we see the drop off on the performance of the flow sensor through the controller. So there's only a few, controllers that can really see the data, the pulses that are coming in, and we can see the performance between the different flow sensor ranges. Where we have really noticed the issue is on the 2-inch, the 228s, where they drop off or they start at 10 gallons per minute. So a lot of our, MP rotator stations, tree bubbler stations that can operate correctly less than 10 gallons per minute are simply missed. So our teams are having to turn off flow on those particular stations, and we're losing out on all that performance and features on those stations.
Yeah, absolutely. And so when you are choosing a flow sensor, what's your process? How do you analyze a system to determine which flow sensor you'll choose?
Yeah, that's a great question. So, we were, basically we all love the 228s, right? The 228 PVs, the plastics. We've been using
Those
those
are
for
the industry standard data industrial flow sensors, right?
That's correct. Yes, yeah. So we've been using those for the last 10 or 15 years. We haven't really seen too much improvement performance-wise with them, the ranges and what have you. So it was really interesting when we started seeing the creative sensor technologies, the CSTs coming in, because of the better performance basically at the same price point. So we have started to use those. And then when we have areas where we don't have the ability to capture the straight pipe requirement, the 10 times and the 5 times the pipe diameter, that's where we've been selecting the hydrometer. So, we definitely have to make sure that not only are we in the right flow ranges that we need to be in, but there really is a product for each application. So just understanding, what products are out there and how we can utilize them correctly.
And another great.
It's also important to consider pressure, because the PVCs are rated for a certain tolerance for outdoor versus indoor, and water pressure can force you from plastic to brass or from plastic to cast iron. So
that's a great point.
As well.
Yeah, I guess we can say that we're typically privileged. In Southern California, we get the water sources with the clean, even recycled water is relatively clean. And we don't get above typically 150 psi without starting to talk pressure regulation and whatnot. So you're absolutely right, though. We've had to make those calls. I'll never forget, I have seen a flow sensor blow out of a valve box. And I know it probably hit about at least 15 feet up in the air because it took the wire with it. So you can definitely see that pressure, yes, is an issue. That cotter pin that comes across took that Schedule 80 with it. It was very interesting.
Did it dig a trench where the wire just pulled out?
Well, if it wasn't for the valve box, it would have. It was very interesting.
That's awesome.
So now that there are high definition plastic flow sensors that could insert into that 228 body, when do you decide whether traditional flow or high definition flow is important?
Well, I mean, ultimately, my concern is I think we had some issues with the FlowMech inserts working with the existing Ts. I think that's all been solved. I was going to be a guinea pig for that about 2 years ago. So now that that's been solved, we really do try to push the FlowMech, through the retrofit process, obviously to pick up the better performance. Really haven't seen any issues with it so far. My experience overall with those has been relatively limited because we kind of shifted from the 228s, the data industrials, to the CSTs, and now time will tell. The more history and more consumption we have on those FlowMechs, what that's going to look like.
And when you talk about the FlowMech, we're talking about the Flow HD plastic, right?
Yes.
The WeatherTRAK Flow HD plastic.
Yes, sir.
But no, you're fine. But what I see, one thing that you said earlier rang true, talking about the installation of those devices, along with the T-style flow sensor as well as the HD plastic. We've got a number of installation challenges, we'll say. It has to be done very specifically in the correct way. And if it's not, I've been the bearer of bad tidings to many an installation contractor that said, hey, you don't have the correct distance or you're not using the right size. So one of the things that I think is important is understanding the hardware and understanding the space requirements and knowing that different types of technology have different installation instructions.
Yeah, it's been very interesting. I'm coming on to about 12 years in the industry, and seeing that flow sensing kind of came in during that time, watching the straight pipe requirements not being met. We've seen not the right wire, not the right wire splices, not correctly inputting the right K value and offset values. That's a fun one. So yeah, I mean, it's really just not a set it or forget it, and what I really try to preach is good data in, good data out. We really have to respect the controllers. We have to respect the equipment. If we do all of this correctly, if we set the baselines correctly, if we set, the mainline thresholds correctly, we're going to get better performance out of the system.
And how does that message come across to your customers? Like, is that something that is, it seems self-evident to me. Is that something that you're having success just talking about with people who aren't elbow deep in irrigation?
We're getting better. You know, the interesting thing is that when we've seen people that have, and this is the irrigation folk, when they've struggled with flow sensors, it's very quick to turn the off switch, the light switch off, right? So they disconnect the flow sensor, they turn them off, what have you. So really, you know, the last couple of years has been my battle of flow or no flow, and it's only been really recently with you know, OptiFlow and you know, bringing more attention to flow sensors that now we can talk about, well, great, now you know, we had the flow sensor on, how was it working for us? What settings were there or not there, and what kind of feedback were we actually getting out of these controllers? So that's been a very interesting challenge, talking with the board members, talking with our end clients, is making sure that they actually understand the value of this equipment.
And
so Danny, one of our attendees has asked a question, and maybe you've got some insight for her. Can you provide recommendations for a line of sight wireless flow sensor transmitter and receiver combination if hardwiring a flow sensor is not feasible?
Interesting. So I would actually implore, I'm a hardwire guy. I always prefer hardwire. So I would implore looking to see if a flow link would solve your particular issue in that capacity. I understand that WeatherTRAK did have, or does have, wireless flow capacities. Had. Very good. What we have found with wireless flow is they're kind of dependent on typically 900 megahertz radios. So line of sight is obviously a big issue. Total distance is an issue. When the FedEx truck decides to drive by, you know, is an issue. So, you know, we've kind of really stayed away from wireless flow. The only thing that, you know, we can really try is through OptiFlow or other means, FlowLink, to make those connections. So, you know, I know other manufacturers have wireless flow. I'd argue against, you know, what value and how well it's going to actually work out for you in that application.
And that was one thing I was going to highlight, was the OptiFlow opportunity there, right? I agree. I haven't seen reliable proof of a wireless solution yet, but if you do have electricity, OptiFlow, if you put an OptiFlow controller out there, you can just listen to that flow sensor and add that into your network. And I've seen that be a good solution for some folks.
Danny, you mentioned FlowLink, which some people do call wireless flow, but in a sense, if you can't run a pair of wires from the master valve and the flow sensor back to the control, FlowLink uses decoding technology to borrow the wire that's already a good wire running from the nearest valve box. And so you trench from the POC to the nearest valve that's working, tone that out, make sure it's a good connection. And then it'll pulse the signal of the master valve, the flow sensor, and the station wire back to the controller, and then decode that. So for our audience that is wondering about, you know, some people call that wireless flow. It's not. It's really an anti-trenching borrowed wire solution.
Yeah. If anybody's not aware of the FlowLink product, I do implore you to check it out. It's a very nice piece of equipment. We have used it in, you know, multiple applications. We have actually used it in areas where trenching was still feasible, but looking at the total length and the cost of labor, we still actually decided to go with the FlowLink, which I think was very interesting. I think a lot of people just say, you know what, let's get the ditch witch out. But it worked out for us. It worked out very, you know, like you said, you got to make sure that your station wire is healthy, that you are within the tolerances of the manufacturer's spec. But we have had great success with it. Good splices. Make sure you do your splices well, and you know, we've been happy with it.
For any other audience member with an application for wireless control like that, please feel free to message us and let us know. We sort of keep an informal running tab of what market demand would be for this kind of solution, and we are under investigation of a number of other technologies that aren't yet in the market that could potentially be brought to bear on this problem. So we'd love to hear from you about your interest and need in those areas.
That's awesome. So Danny, one thing I was brainstorming as we were talking about this subject, one of the things I like to do on the weekly webinar is demo and show in the WeatherTRAK technology what the subject of the day and how it applies. So I'm going to jump into that real quick. And what I thought about for this particular subject, if I can quit this, go to weathertrak.net here. Oh, not Zoom.
Well, you're not on my account, right? Okay. I want to make sure you weren't on mine.
I just out of curiosity, Danny, how many WeatherTRAK controllers are in your file?
Oh, I think we're a little over 1,300 now.
Nice. That's a good number.
Yep.
All right. So the clearest way that I can detail the incorrect selection of a flow sensor, as detailed by Danny's kind of criteria, is we have built features around the limitations of that field hardware. So Danny said you have to turn off the flow sensing, and that's exactly what we do. If you have a 2-inch flow sensor, right, that is only capable of a minimum flow of 10 gallons per minute, then when that station is running, it'll still measure, but every once in a while it's going to miss a pulse, and for that split second, it will measure 0, and the controller will create a false, or it will detect no flow, so it will tell you it detected no flow. So what we have to do is come in and exclude the stations that are below the minimum reading for our flow sensor from both no flow and low flow alerts. And that really leaves a lot to be desired, right? That isn't exactly what we want to be doing. We want to be tracking all of the gallons that are running through that system. So if you log in right here, you can see that just based on industry standard hardware, we got these questions repeatedly and had to build software to make that work for people in the field. So that was the quick demo. The other thing that I see in this is the subject of low flow comes up a lot. And for many, many years, it was the only part of the conversation that I really even heard until OptiFlow came along. And now with OptiFlow, I see people selecting the wrong flow sensor because of the high-end tolerance. Like just last week, I had a contractor who put OptiFlow on a site that had two 2-inch point of connections and a 4-inch main line running through. And the 2-inch flow sensor is only capable of managing up to about 95 gallons a minute. And in that looped mainline configuration, either one of those points of connection could be running upwards of 120, 130 gallons a minute. And so you got to really understand what the system is doing, not only on the low end, but also on the high end.
Mm-hmm.
We have another question that's come in. How often do you suggest relearning flow for changing site conditions?
Great question. So there's a couple of different times we're going to want to relearn flow. Ultimately, every time that we do a PMI, preventative maintenance inspection, wet checks, if we're going to go through and take the time to go through and repair, identify and repair everything, it's worth our time to relearn the flow after that. We know all the stations are operating correctly. We know we have healthy baselines. No valves are passing water. We're able to get a nice healthy snapshot of the flow at that time. Another instance where we're going to want to relearn flow, and this is more at the station level, is when we change a station. So we change out the nozzles and the PGPs. We decide to go from Rainbird MPRs to Hunter MP rotators. Anytime that we change the application or the precipitation rate of a system, or even an irrigation method of a system or a station, we're going to have to relearn flow. This really just goes back to bad data bad data in, bad data out, good data in, good data out. Making sure that you are operating at what your controller thinks that you're operating at. These systems, and I'm going to say this the nicest way I can, but they will fight you. If you decide to go up against them, it's just going to make it very frustrating, and a lot of people tend to turn the flow sensors off. But I am trying to work with my teams and with the industry on trying to elevate us to the next level and getting all of these flow sensors up and running and programmed and specified correctly.
Absolutely.
The other thing that I'd add to that is when you learn flow, stand back and look at the results for each of the stations. And if you see two rotor stations with literally the same precip rate that are irrigating the same turf panel in the same conditions, but one seems to be higher than the other, do a count of the number of heads to justify to yourself that the flow is properly measured, or visually inspect by turning flow on and see if you've got a blown head. You know, and if you want to make that repair and then relearn flow, that's another good opportunity to relearn flow on a station.
Absolutely. I can see that very regularly. When I'm learning flow remotely for my customers, after the WeatherTRAK does the learn flow test, I can see that there might be one or two stations that are way out of like the design range. Everything's running at 50 gallons a minute, and there's that one that's running at 90. You know right then, even with the learn flow value, that that's something that you want to investigate.
Another question for Danny. Can we talk about flow alert clearing, auto versus manual? Which do you prefer?
Great question. So I actually, it really depends on the quality of the technicians on the site, what the level of training that they have. The way that I see it is the auto will simply just continue to check that same station every time it needs to irrigate. So at minimum, let's say we have checks or monitoring coming in at 3 or 6 minutes. We know we're going to get at least that much of irrigation down. It can kind of, you know, sometimes hide our problems, you know, because hey, the turf looks wet, it must have watered, there's no issue. But at least we're guaranteeing some movement of water and some irrigations occurring. The manual, if you don't have the right supervisor or you don't have the right people in place, labor is an issue, the job sites, you know, out in the boonies, that's where that manual can kind of go against you, because not only could you be possibly picking up higher depletions and starting to get into your depletion issues, but you're not going to be irrigating those stations. So something as a false positive low flow or a high flow could be disrupting all of that irrigation from occurring. For example, a false mainline break. You know, you're not going to have any of that irrigation occurring until that mainline break is cleared, and that can cause an issue to your landscape. So if you have the visibility, if you have the labor, and you have the skill, auto I think is the right way to go. If you don't have the supervision, you have to be a little bit more careful with the manual.
Thank you. We got another question for Danny. Do you use a sliding scale for percent offset for station high flow, or is it a constant regardless of GPM for each zone?
Great question. So it really depends on the range of the system. So we learn flow, we know all the data is good. If we have 36 stations and we are, you know, some stations are 10 GPMs and they're healthy, and then we have some 70 GPM stations and they're healthy, us allowing a positive or negative 30%, that's a huge swing, right? So a 30% swing on 10 GPMs is about 3 GPMs. So we're allowing 7 to 13 to occur on that 10 baseline. If it's a 70 GPM station and we're allowing plus or minus 30%, that's a lot of range. That's more range than I actually feel comfortable with. We're going to allow 3 turf rotors to get run over by a truck, and I'm not going to get the alert. That's not okay. So I definitely suggest, you know, having your 20 or 30, 40% baselines, but then going into your user entered areas and adjusting your flows in those parameters. The more time you spend with it, the more you understand your system, and the more pressure regulation you have throughout your system, the more easier it is to manage all those different flows.
Absolutely. So Danny, just to summarize here, what would you say to the average contractor is a good rule of thumb when selecting the flow sensor for their project?
Ultimately, irrigation plans are great. But your mechanical water meter, the one the water district puts in to make sure your bill's correct, I would definitely check your performance of the water meter against the flow sensor. We just want to make sure that, you know, the flow sensor is reading 30 GPMs. You have the K value, offset value, make, model, size in the controller. But doing a mechanical check against the flow sensor is a pretty good idea. And then understanding what you're expecting on that system. So If your lowest flow is 17 GPMs and your highest flow is 55 GPMs, you're getting into that point where you don't want to use the 1.5-inch hydrometer because he's stopped at 55 GPMs, and so that 2-inch flow 3 might be looking a little bit better. So really just understanding the flow ranges, why they're there, what the margin of errors mean, and making sure that you're sizing up correctly, sizing up or down correctly.
Awesome. Great insight. And last but not least, I know we were running out of time, but I ask all of my guests, what does WeatherTRAK save you, Danny Smith?
Time, money, and I mean, to really just add to that, it allows me to get our industry to be better. We have essentially been allowing our irrigation technicians more time through the HydroPoint University. I truly feel if our technicians understand the WeatherTRAK product, it's a lot easier for them to understand all different types of programming, user with ET, fully auto, how management allowed depletions work. So I really like to use WeatherTRAK as a training program to help them understand the rest of the industry. The way that you guys have not just allowed a low flow alert to come into my inbox, but then give me a full description on what the problem could be, how we could fix it. Here's a link to our video on how to fix it. Here's a link in Spanish to the video to fix it. That's just power, that's what's going to help our industry progress and move forward. And I'm looking forward to it.
That's awesome. Great insight. And with that, we are going to duck back. Oh, get back into the PowerPoint world here and give a plug for next week. So as usual, we are here to support you in all your water management needs. If you have any questions or need any support, you can always contact our customer support team at both the support@hydropoint.com email address or the 800 number, where they provide Spanish and English bilingual support 6 days a week. If you are a self-motivated learner, you can check out our online resources, both at support.hydropoint.com, where you will find our knowledge base and articles that will help you troubleshoot, as well as the resources available at our website, where you can find all of the tech specs and all of the information. And then, like Danny mentioned, we also have online training available for anyone who's interested. So go to hydropoint.learnupon.com to check out your certified, on-demand, and free WeatherTRAK training. And that brings us to next week's conversation. We start to really delve into the summertime blues here. We have 2 weeks back-to-back of really summertime topics. The first one is water restrictions and managing your WeatherTRAK during water restrictions. We'll have Ryan Griffin, a great water manager from Site 1, join us. He's a great water manager out of California. And look forward to seeing you next week. Mr. Slick.
Thank you for those of you on the chat that let me know my audio was a little weaker than it should be. I'll try leaning closer into the mic going forward. But thanks for your questions, good ones today. And look forward to continuing these series. You guys make this possible for us, so thank you for letting us do it for you.
Absolutely. And I likewise thank you for being here and appreciate you tuning in. Look forward to seeing you next week. Danny, you want to send us off?
Have a great day, everybody. Stay safe. Wear your mask.
Thanks, everyone.